The essential question in this video is, how can I use triangle proportionality to find missing measurements? And the first thing you want to do is to define triangle proportionality. And here's the definition. If a segment intersects two sides of a triangle and is parallel to the third side, it divides the two sides it intersects proportionally. So this is the end in parentheses, and it creates similar triangles. So it's kind of hard as you read through this definition class to really make sense of all the different things you're being told. So let me explain that on the diagram. Okay, when it says if its segment intersects two sides of a triangle, which is segment EB intersects two sides of triangle ADC, and it's parallel to the third side. Let's go ahead and mark that. So that's saying that not only is there a line that touches two sides of the triangle, but it's parallel to the third side. So in this case, EB, our segment inside the triangle, is also parallel to side DC. If those two things are true, then segment EB divides the two sides it intersects proportionally. That means this side right here, AD, and this side right here, AC, have been divided proportionally with points E and B. Let's write that out in math terms. So we're going to say if EB is parallel, if segment EB, and then remember these two lines right here, I'm going to write them a little clearer for you. These two lines mean is parallel to segment DC or side DC. If those are parallel, then this proportion is true. Then AE divided by ED is equal to AB divided by BC. So it creates a special kind of proportionality. Now I want you to see something. As you go through these problems, you're going to see how I set these up. When you set up your proportions, take a look at AE. I'm going to go ahead and label this as 1. And then ED, I'm going to label it as 2. And AB, I'm going to label it as 3. And BC, I'm going to label it as 4. I want you to see when I set up my proportion based on triangle proportionality, 1 goes in the top of the first ratio, 2 goes in the bottom, 3 goes in the top of the second ratio, and 4 goes at the bottom. Now, no matter how I turn my triangle, I'm going to show you, you're going to set your proportion up this way. 1 over 2 equals 3 over 4. In fact, take a look. It kind of looks like 1 and then it divided by 2, and then 3 divided by 4. Okay, we're going to show that application of the triangle proportionality in a moment. One more thing I want you guys to see is, take a look at this. If EB is congruent to DC, you learned last year that means we have created some congruent angles. So we can actually write here, since angle AEB is congruent to angle ADC. Take a look at this. AEB and ADC. You learn that these two angles are called corresponding angles. We learned last year that if you draw two parallel lines, let's do that. If you draw two parallel lines and then you use a transversal to cut across those two parallel lines, you learned last year that, oops, let me put that back to orange. You learned last year that this angle right here and this angle right here are congruent because they're corresponding angles. So we created corresponding angles here. We also have two more angles that are corresponding. It also created angle ABE, and that is congruent to angle ACD. Same thing. These two angles right here are corresponding angles. And now if you look at that, We have a triangle on top, triangle AEB, the smaller triangle, and the bigger triangle ADC. Those two triangles now we have just proven are similar. Since those two angles, pairs of angles, are congruent, then triangle AEB, the smaller one, and triangle ADC, the bigger one, they are similar. And by the theorem, by the AA theorem, by the angle theorem. So when you put a parallel line inside of a triangle, you create a small triangle and a big triangle, and both of those triangles are similar to each other. If you can't see that, let's just take a look at this. We can I'm going to sketch this out for you and show you this. Here's the smaller triangle right here. I'm going to try my best to sketch it kind of like the drawing. There is a E, B. If you take a look at that, there's the smaller triangle on the top, AEB. And then we've got a bigger version of that. That is ADC. And since we know that these two angles were shown to be congruent because of corresponding angles, and these two angles are shown to be congruent by corresponding angles, take a look. There are two triangles with two congruent angles. That means we know those triangles are similar. We've already proven that. And because of that, we could also do this. We could circle the angles, or the vertices that are congruent. I'll put that as single circle. I'll put the C as double circle. And we can actually write a proportionality statement. We could say that, let's do E to B, so single circle to double circle, and then the other triangle, single circle to double circle. And then we'll go double circle to no circle, so BA is proportional to CA. And then our last one, AE, is proportional to AD. So I just want to see that you can actually look at these two triangles. We've created similar triangles. That we already know. This is the new part we're learning, that we've created a proportionality between the two sides that have been cut by this parallel segment inside. Let's go ahead and do some problems and see how that plays out. So here's our question. If BC is parallel to DE, hey, if they tell me that, I'm going to mark it. If BC is parallel to DE, what is the length of BD? Now take a look, class. See how I did on the first one? I put the parallel lines on the bottom of the two triangles, then I labeled 1, 2, 3, 4. This is a good trick for you to use to get these things lined up. So I'm going to write here, this is 1, this is going to be 2, this one's going to be 3, that's your segment, and this is going to be our fourth segment. So we're going to go ahead and write our proportionality statement based on what we know about triangle proportionality. We know that segment AB, there's the first one, segment AB, and then our ratio is going to have this next segment, the smaller segment, that's BD, and that's going to be equal to, here's our third segment, AC, and that's going to be over top of our fourth segment, CE. So we know, based on triangle proportionality, that that statement is true. Now all we have to do is plug in our numbers, and let's go ahead and solve for the missing part. They want us to find BD, which has an X at it. So let's take a look at AB. AB is 16. BD is our unknown. AC, now let's be careful here. AC, they don't tell us AC. They tell us AE and CE. We're going to have to find AC. So be careful about saying that AC is 30. It's not. AE is 30. So to find AC, we're going to take the whole line segment AE, and we're going to subtract the one we're going to cut off on the bottom, CE. That's going to leave us with AC. So AE is equal to 30, and CE is equal to 10, and that means AC is actually equal to 20. I'm going to label that right here. So we have to find that segment because it hasn't been labeled. So now we know that AC is equal to 20, and CE is equal to 10. So now we have our ratio set up. That's going to go ahead and cross multiply. So we've got 20x is equal to 16 times 10. 20 in x, I put 20x, 16 times 10. 16 times 10 is 160. Let's divide both sides by 20. Let's do that right now. So I'm going to move my calculator over here. And we've got 160 divided by 20, and that equals 8. So x is equal to 8. So now remember, that's not our final question. The question is, what is the length of BD? So at least, very least, what I'm going to write for my final answer is BD equals 8. And then I don't have a unit of measure here. There's no feet or inches, so I'm just going to write 8 units. There is my final answer. Whoops, that's a bad circle. You want to circle your final answer. Alright, so we just used triangle proportionality to find this missing length BD. Let's do. Before you continue with this video, draw a question mark in the bottom left-hand corner of this page. The bottom left-hand corner of the top flap of section number 7. Draw a question mark there on the bottom left-hand corner. Do one more. If PQ is parallel to KJ, so we know that PQ is parallel to KJ. That means we've created two similar triangles, a big one and a small one, and triangle proportionality is going to work here. What is the length of SJ? Alright, well, let's set up. Now, I can't do this on the video, but what I want you to do is I want you to turn this triangle around so the two parallel sides are on the bottom, just like our first example. The two parallel sides are on the bottom, and the point that doesn't have a side touching it right here, it doesn't have, sorry, let's just say it's the side that is not parallel to the other two, or this vertex right here is not part of the parallel lines. Put that one on top. So turn your paper 180 degrees over, and you're going to see when you do that, let's label them just like we would have. This is going to be 1. This is going to be 2. Then we go back to the other side. This is 3. And this one is 4. Now this won't make sense unless you're listening to me on the video, so you understand you're turning your paper upside down so the two parallel lines are on bottom, and then you're labeling them just like this. 1, 2 on the left, 3, 4 on the right. Once we do that, now we can set up our proportionality. Sorry, I hope you guys could see that, those two examples. Alright, let's write our proportion now. So we've got SQ, here's our first one, over QJ is equal to SP over PK. There we went 1. Again, I'm going to note this so you see this. We did 1 on top, 2 on bottom, and then in the other ratio, segment 3 on top and 4 on bottom. Now we've got our proportions set up. Let's go ahead and figure out what our missing value is. So, do we know what SQ is? No, SQ is an unknown. It's asking you what the length of SJ. Oh, so they want to know what SJ is, but we can't find SJ until we find SQ. Then we'll know SQ and QJ, and then we can add them together. So we still have to find SQ. So SQ is going to be our unknown X. QJ is 5. SP is 7. And KP is 2. Let's go ahead and cross multiply now. So you've got x times 2 is 2x equals 5 times 7. So 2x equals 35. And if we divide 35 by 2, let's do that. 35 divided by 2 equals 17.5. So x is equal to 17.5. Well, that means we found this value right here, SQ, and that is equal to 17.5. So now our final question is, now we have to find SJ. So I'll put a little note here. Now find SJ. In fact, why don't you put up here, and the first step is step 1, let's find SQ. To find that SQ first, and here's where we found it right here. Now we're going to find SJ. SJ is equal to SQ plus QJ. And SQ is 17.5 and QJ is 5. So SJ must be the sum of these two, which is 22.5. So now we found our missing length. So when you read these, be careful, because in this case they want to know the whole side length. We had to find the smaller one first, and then we're going to add it to QJ, and that's going to give us the whole of SJ. So our final answer is going to be SJ equals 22.5. And again, looks like they didn't give us a unit of measure, so we're going to have to just write units. And there is our final answer. I'm going to, instead of circling that, I'm going to put a box around that. Makes it a little bit easier. And there is our final solution. So that gives you an idea how to use triangle proportionality to actually solve for missing parts of a shape.